Hey, Assalamualaikum. This Asus, who is this Asus? Your name is here, you should be here. Who is this guy? I thought I asked you to put your real name. Who is
Sorry, sir, because I did not know how to change the name.
can you change your name? Put your real name. If you don't know how to do it, ask somebody. Okay, put your real name as in the name list. Well, what is your name actually?
Elvin.
Elvin. I saw you in the WhatsApp. Put your real name, okay? I thought, who is this? So Elvin, there are two things that you need to do. One, put your real name. Don't put Asus. The other one is in the WhatsApp. Can you put your name in English? Okay, because I don't understand Chinese character. Okay, boleh ya?
Okay, later.
All right. So do that. That also apply to other people lah. For those other people, if your name here, is not your actual name, please change your real name. And then there are still a few students who have not put your picture. So again, please put your picture so that I know who you are. Okay, all right. Today we're going to continue with our discussion. We were talking about the application. The lesson that we did was on the depreciation. I give you a few questions. Is there any problem with the questions about the application? I'll give you 49, 51. So the purpose of this question is to be able to find the slope, describe the slope, and also describe the intercepts in terms of the application. Okay, all right. Okay, one more thing. I already formed the, what do you call it, classroom. And I put link in the WhatsApp. So join, okay? Because probably by next week, I'll give you first homework, okay? By next week. And then also in the WhatsApp group, I saw a list, okay? I haven't checked the list. I saw the list of which you can find your group member. So, you work among yourself to form the group. So like I said earlier, you don't have to know the person that you're going to be in the same group with. It doesn't matter who, but the most important thing is we'll be able to discuss and work together to do the homework questions and among other things, to what do you call it? To discuss the material. So we're going to continue to the next part. Now the next part will be 1.6. 1.6. 1.3, 1.4, we are done. Yeah, no, 1.5. So next thing we are going to do 1.5. All right. 1.5, we are looking at the system of linear equations. So that will be our next part. So 1.5, system of linear functions or equations. Now, when you have a system, what does it mean? A system is where we have two or more equations. So that will be a system. So a system of linear functions. System of linear equations. We can also call it functions, but equation will be more general because sometimes we deal with a linear equation, function. So to me, you can use either way, doesn't matter. Where you have what? You have two or more equations at the same time. So in terms of mathematics, we call it simultaneously. You have the two equations simultaneously. Now, when you have that, you want to find the solution. Okay, the solution. Simply put, what is the solution? The solution is, if you go by the graph, okay, we go by the graph, we can see the solution quite easily, because by looking at the graph, it is the point, all right, point of intersection. It can be one point, points of intersection, points of intersection of all the equations in the system. So you have a system, you have two or more equations. When you want to find the solution, that means you want to find the points of intersection. That means the point or points that satisfy all the equations at the same time. Satisfy all the equations at the same time. Now, it can be a few possibilities. Number one, there is only one point. We call it unique solution. Okay, there is only one point. Number two, it can be infinitely many points. Infinitely many points. That means unaccountable. Infinitely many points. Number three, there is no point. Okay, no point means there is no solution. All right. So there are three possibilities. The one that we are very interested in, our focus will be this one. Okay, we want to have only one point. If there are more than 1 point, too many points, or there is no point, there is no point of finding the solution. So for a unique point, that is our focus. We want to have a unique point so that there is a direction to where we will go. If there is no point, or if there is infinitely many points, then we actually do not know where to go, all right? So our focus will be unique point. So graphically, we can show the solution and we can get the intuition of the solution. So let's start with a system. Now, a system is where you have two or more. So let's consider two equations. All right, we start with a system of two equations. Let's say I have y equal to m1x plus b1. We call it number one. And then we have a second equation, m2x plus b2. That is equation number two. So let's do the graphical way. I have here x, y, 0. Suppose this is number one. All right, and then that is number two. So as you can see here, the solution is point or points of intersection. So you'll see here the common point. So you call that point. So that is the solution. So E, right? Sometimes E can be, we use E as equilibrium. Okay, equilibrium point, or E is the solution. So we work by E. So E is the solution. That is the point of intersection. As you can see here, there is only one point. So we denote that point as X star, Y star. So the solution, or the point that satisfies the two equations at the same time, is the equilibrium point or the solution. We denote that by what? Denote by x star, y star. So that is the solution. And here you have unique solution. There is only one point. There is only one point that satisfies the solution. Oh no, the solution, the system. Okay. Any question about this? All right. Okay. So what we want to do next is that since what we are interested in is the situation number one, where you have a unique point, okay, a unique solution. So that is what we want to go into a little bit more detail. How can we identify from the system that we actually have a unique solution? How? All right, this is how. Here, okay, here I give you one example, all right, where you have one solution. And the conditions are based on the value of the slope and the intercept. So I will give you a few examples. Oh, no, I want you to sketch, right? A few examples. When do we have a unique solution? Before that, okay, here there is a unique solution. What can you say about the slope of the first equation, the second equation? What can you say about the slope of the two lines?
Slope 1 is positive, slope 2 is negative.
So here, all right, you see here one slope is negative, M1 is positive, M2 is negative. So you will have a unique solution, all right? But that is not the only possibility. You can also have the slope, both are positive, M1 positive, M2 positive. Okay, I want you to sketch a graph. Show that both M1 and M2 are positive, and you still end up with a unique solution. Okay, just sketch. You can sketch it on the same diagram here, or you can draw another diagram. Just sketch another system. Okay, both are positive. Do we have a unique solution or we don't? Okay, anybody got a unique solution? Both slopes are positive. Do you have a unique solution or you don't? Anybody who get it first, let me know. Ay, tak ada orang dapat ke? That is X. That is Y. Okay, you draw two lines. You know, equation 1, equation 2, both have positive slope. Do they have a unique solution?
Yes, we can have the unique solution.
Okay, what is the condition on the slope for them to have a unique solution?
They both needs to be positive.
They are positive, I know. But what is the condition on the slope so that you have a unique solution?
They must
First,
be intersecting.
intersecting. First,
You
positive
get one.
and intersecting.
Right, you got one. And then what you do, you draw another line, positive slope. See, you draw the line positive slope, you also end up with one unique solution. Okay, so here both can be positive. Now, can the slope be both negative? And you have still unique solution.
Yes.
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 Okay. If you draw two lines, both are negative. One, and then there is a line number two. You see, both are negative. You also end up with one unique solution. Okay. So you will have the condition, all right, for your unique solution. The condition is M1 is not equal to M2. So for a unique solution, the only condition is M1 not equal to M2. Can be one positive, one negative, both positive or both negative, it doesn't matter. All right. Now, what about the intercepts? Is there a condition on the intercept? All this, we already have all this drawing. What about the B? Is there any condition on the B? Do you need the B to be different? Or can B equal? Can B1 equal to B2?
If it's equal, there's no intersection. It's going to be parallel.
No, yeah. Okay, you do this, all right? You do this. You make the slope not the same, all right? You make the slope not the same, but you make the intercepts B1 and B2 the same, and see that we will have a unique solution. You make the intercept summer, the slope different. You sketch the graph. Where is the solution?
So we can say that positive and negative, dia punya intersection near the same place.
Intersection same place. Slope doesn't matter. It can be as long as the slopes are not the same. Okay, we should have a unique solution. So if you got it, where is the solution? Okay, you sketch the line B1 equal to B2. So let's say I take B1 here. I take this line 1. So the intersect is there. You draw one more line. Intersect is the same point there. What happened? Is there a solution or is there not a solution?
No.
Everybody, okay? I want everybody to draw one line. Okay, I already have the first equation, the blue line. Same intercept. So intercept is that one, that point. So you draw another line, intersect, y-intercept, the same thing, the same point. Draw, doesn't matter, the slope to positive or negative, as long as it's different than the blue line. You should get a unique solution. Where is that solution? Did you get it? Did you get what I'm trying to tell you? This is the intercept. The intercept of the second line will be equal to that intercept. So you draw the one straight line at that point. Okay? So what do you get? What do you get the solution at? You draw another line. Okay, like this. I draw another line. They meet. So we must that point now. Okay? Suppose intercept are the same, right? But I miss a little bit. If you draw it nicely. So that is number 2. Is there a solution or there is no solution? Intercept ni sama ni. Is there a solution? This is equation number 1. That is equation number 2. you have the same intercept. Is there a unique solution, or is
Yes,
there?
yes. There is solution.
Where is the solution?
On that point,
That point,
the one
solution.
that equilibrium. Yeah.
That intercept is the solution. Okay. So for unique solution, the only condition is just M1 not equal to M2. The intercept doesn't matter. Okay, it can be the same, it can be different. So as long as M1 is not equal to M2, there will be unique solution. So it's easy to see. If you have a system, first thing that you do is you check the slope. If they are not equal, that means there will be unique solution. If the slope are equal, then different story. Okay, so now that is where we are going to do next. Number 2, what about if the M1 is equal to M2 and B1 is not equal to B2? So the slopes are equal, but the intercepts are not. Okay, so is there a solution, or there is no solution?
No solution.
No solution. Okay, you have one line, the slopes are equal, intercepts are not equal, so they are what? They are parallel. You have a parallel kan? You draw 2 lines. You draw one line first, and then you draw another line. The slopes are the same, intercepts are different. So you will see parallel line. Okay, all right. So if I can draw it here, I draw another graph. So you see here, x squared. I have one line, call it number 1. And then you have another line, number 2. Slopes are the same. So slope the same slope, but intercept are not equal. Let's say intercept is over there. And then slope are the same. You draw it, it will be like that. So these lines are actually parallel. So when the slopes are equal, intercepts are not, you have parallel. And here, okay, number 2, there will be no solution. So here, no solution. Okay, so no solution. You have same slope, different intercept. So there is no point of trying to solve it. You will get nothing. Even if you work until next week, you will get nothing. Okay, so that is no solution. Now the third situation, you have the slopes equal, M1 equal to M2, and the intercepts are also same, are also equal. Yes. Equal. Tapi saya tulis tak equal. So you have your equals ini pun equal. So if M1 equal to M2, B1 equal to B2, what happened?
Same line.
You have the same line. Okay, same line. That means the two equations have the same. The 2 lines have the same equation. So you have 2 lines. Both of the lines have the same equations. So you can think of it, they overlap. Okay. So if that is the case, then how many solutions do we have? So number 2 here is, you have this line overlap. Tu dah. Apa solution dia sini? No solution or what?
No solution.
Apa lah? No solution. No solution.
Infinite.
Infinite.
Every
Infinite.
point is a solution. Okay, every point is a solution. So you have infinitely many solutions. Every point is a solution. Infinitely many points. Okay, infinitely many solutions. So this one we are not interested in. So if you see a system, slope dia sama, intercept pun sama, tak payah cerita. Okay, you don't have to do anything. Just say that they are overlapping, so there will be infinitely many solutions. So in order for us to solve the system, you just look at the slope. Okay, just look at the slope. If the slopes are not equal, then there is a unique solution. If other things, then you may have either no solution or infinitely many solutions. Right? Okay, good. So in order for us to find the solution, we are using the method of substitution. Ni apa ni? No, sir, what do you mean? Okay.
Oh, tak, itu silap tengah ni, sir. So,
All right. So we are going to do a method of substitution. Now we're going to do this by an example. So to find the solution, we're going to use the method of substitution method. Substitution method. Okay, all right. So we do by example, and the method will be, will be the same. So example, let's say I have y equal to negative 2x plus 25 lah. And then second equation, you got y equal to 3x minus 10. So that is number 1. That is number 2. So our method is very simple. Substitute. So you can do either substitute 1 into 2 or substitute 2 into 1. Substitute 1 into 2 or 2 into 1. So let's say I do the substitution 1 into number 2, because both are y equal to, right? So substitute 1 into 2, what do I get? I get negative 2x plus 35. Yes. Do you want to say something? 3x minus 10. So you bring the x to one side, the constants to the other side. I have negative 2x minus 3x equal to negative 10 minus 35. Yes? Is there anything? Okay. I thought somebody want to say something. No. All right. So that is negative 5x equal to negative 45. Is that right? 45. So x equal to negative 45 divided by negative 5, that is equal to 9. So x equal to 9. Again, do another substitution in order to find y. So to find y, we do substitute one more time. X equal to 9 into either 1 or 2. X equal to 9 to 1 or 2. It's up to you, all right? Into 1 or 2. Okay, this is what I want you to do. I want you to find the value of y. So if your name is from A to N to M, okay? A to M, you substitute into 1. If your name is from N to Z, you substitute into 2. Okay, do it now. The value of y.
It's 17.
Yeah, I got 17.
Then the question was nothing. Look at nothing. No, that's of course. Oh wait, that's
Okay, you got it?
Yes.
Okay, what do you get?
Yes.
17.
17. Everybody got 17?
Yes,
I got
17.
Okay, good. So everyone got 17. So let me just do one of them. So let's say I substitute into number 1, all right? And see what we get. Everybody gets 17. So I must also get 17. If I don't get 17, that means something wrong somewhere, you know? So you substitute x equal to 9, say into number 1, okay? All right, so you can do, some of you did 2 and some of you did 1. So substitute into number 1, we get y equal to negative 2, okay? You multiply by 9 plus 35. So you got 35 minus 18. So 35 minus 18. 35 minus 18, berapa? 9, eh? Betul tak 9?
17.
Huh? 17. That's what you said. You said 17 ke 18 tadi? 17, eh?
17.
Betul.
17.
Okay. So that is equal to 17. Betul tu? Okay. So that is the solution. So the solution is, so we say the solution to the system is x star y star equal to 970. Okay. All right. Good. So that is a system of linear functions. Now I would like you to look at example number 1 in the book. So go to 1.5, example 1. Okay. In my book, 11th edition is page 93. In your different edition, I do not know what is the. So if you look at that example, the system given there is 4x plus 3y equal to 11. You check, make sure that it's the same system. And then the other equation is 2x minus 5y equal to negative 1. So that is number 2. Did I give you question last time? I want to check because I'm not sure whether it's your class or the other class. That I asked you to find the slope intercept. Semua dah buat, eh? Did I give you the questions? This question is on the application. Satu lagi set that I want you to do was to ask to do question. Okay, dah buat. So betul lah. So I think I already give you enough questions already. Saya takut, I'm afraid I got mixed up with the other class. So if you look at this question here, this example, it's a general form. Both are in general. Okay?
The questions we have.
General form. You will see here, graph tu dah tunjuk. So if you want to see how it look like, you can sketch. Okay, just sketch the graph lah. You don't have to draw, just sketch unless we ask you to draw. Okay, if there is nothing, then just sketch because that will be faster. So you sketch the graph, you can see the solution will be somewhere there, like in the book. But you don't have to draw the graph, you just find the solution. That is what we are interested in. Now, what you do here is we have to do substitution twice, because both are in general form. So first thing that you need to do, you have to write the slope intercept form first. Okay? And then only you do the substitution into other equation. So if you look at this system here, so we can start with number 1. So from number 1, I want to write y in terms of x. So I got 3y equal to 4 negative 4x plus 11. Y is equal to 1 over 3 negative 4x plus 11. And that is equal to negative 4 over 3x plus 11 over 3. So you have to do this. All right, you have to do this. That's number 1. You have to write from using one of the equation, the slope intercept form. So easy said, you just write y in terms of x. You can choose 1 or you can choose 2. It's up to you. Okay, it doesn't matter which one because that's your choice. Okay, all right. Then you do another substitution. You substitute into the other equation. So once you do that, you substitute into the other equation. So you got the slope intercept form from number 1. Then you substitute into number 2. Don't substitute back into number 1. If you substitute into number 1, then you are moving in a circle. Okay, you will not get anywhere. You go back to the point of the starting point. So you have to substitute into the other equation. Don't substitute into the equation that you make the adjustment on. And then substitute, okay, y into number 2. Okay, you substitute y into number 2. So what do I get? So we have 2x minus 5y. And that y is the one that we get from number 1, which is negative 4 over 3x plus 11 over 3 equal to negative 1. Itu dia. Betul lah. 11 minus 4x minus 4x plus 11 divided by 3. Betul lah. Okay. So now you have everything in x. So now we can find x. So simplify this. What do we get? We get 2x plus 20 over 3x. Multiply out 5, okay, into terms in the bracket. Minus 55 over 3 equal to 1. Now you bring the constants to the right. Everything x on the left. So you got 2 plus 20 over 3, that is 6 over 3. So I have 26 over 3x equal to kita show the 151 plus 55 over 3. Negative 3 over 3 plus 55. So that is 52 over 3. Betul tak? 52 over 3. 3 over 3. Minus 3 over 3 plus 53 over 3. 52 over 3. So now you bring the constants to the other side. So x equals to 52 over 3 multiplied by 3 over 26. Now that 3 and 3 cancel out. I have 52 over 26. Now 52 over 26. Berapa Siapa ada kalkulator? Cuba.
Sir, it's
Two.
counting, sir.
Amna? Silap. Apa dia silap?
Betul ni, betul.
Mesti betul lah.
Betul ke salah?
Ini betul lah, betul.
Betul.
Ini betul.
Ini negatif 3 over 3 plus 50 over 3, 52 over 3. Nah, belah sini 26 over 3. Ada silap ke? Kalau silap, bagi tahu.
Betul.
Betul. Okay, thank you. So you got 52 over 26. 52 over
X equal to.
equal to what?
Yes.
Betul kan?
Dua.
So 52 tu, you divide by 26, dapat apa? Dapat 2, cantik Lah, 52 divided by 26. Saya akan dapat decimal point. Susah lah. Lama tak buat matematik ni. So equal to 2 kan? Cantik. So equal to 2, you do another substitution. So substitute x equal to 2 into either 1 or 2. Okay? Or you can put into the one that we already do it here. Okay, kak? Boleh kak? Doesn't matter. Alright? To find y. Substitute x equal to 2 into, okay, again here, I want you to do it. Either 1 or 2, okay, to find y. So another practice. So number 1, if your name from A to M, what number 1? If your name is from N to Z, substitute into number 2. Okay, what? Dia dapat berapa? 1. So if you look at the point answer the 1, so kita show lah. You have to show that it's actually y equal to 1. So the solution is 2, 1. Correct? So that is the example. So the reason I show you this example is that in some cases they give you the general form. Okay, they give you a general form. We just do the substitution method. What you do, you have to do the substitution twice. Number one, you make use of 1 or 2, write y in terms of x, and then substitute into the other. So we will end up with the solution, and that is what we call substitution method. Then we are good. So that's it for 1.5. We're done. And I would like you to do another example. Okay, I give you one problem. Let's see what happened here. I would like you to do one question on this. Okay, one question.
It's talking about
Apa dia? What did you say? Sekejap, saya tengah tengok soalan tu. Soalan ni kan dia buat trik sikit.
No, sorry, sir. Just that my dad came in my room just now. My bad. I just noticed I was not muted.
You know what? Are you okay now?
Yeah, I'm okay now.
Okay, good. Okay, do question number ni. Do question number 12. So you go to 1.5. Okay. Do question number 12. That question number 12, yang itu. You got the first equation is 4x minus y. Okay, equal to 3. I write you 2x plus 3y equal 90. So call that one, call it number 2. Okay, so I want you to do this question now. Okay, do it by substitution method.
X is 2, y is 5.
Okay, you got it? It's easy to use number 1. Okay, because
Yes.
one senang lah.
Yes.
Because you got y.
X equal 2 and y equal 5.
X equal to Y equal 5. Everybody got that?
Yes.
Anybody has a different answer? Kalau ramai dapat same answer, that means that's right lah. Alright. So if you I will just outline the method. So what you do, you look at the two equations. It's easy to use equation number 1 lah. Okay, so from number 1, you see here, you got what? I got y equal to 4x minus 3. So you have that, and then substitute into number 2. So you will get 2x plus 3, 4x minus 3 equal 19. So you work everything out. We should get berapa tadi? X equal to apa?
2,
2 and y equal to 9.
5.
5. So that is our solution. Okay. All right. Good. So for your homework, I will give you a few questions. So 1.5, just for your practice. You do question 6 to 8, and then you do 11 to 4, 11 to 17. You have to do all, do some until you're comfortable. And we don't really follow the questions, what you do, you just answer them by using the substitution method. You don't have to do the elimination method. You don't have to do the graphical method. You do. If you want to see it, if you want to see the solution, you just sketch the graph. Okay, sketch the graph. You don't have to draw the graph. Just sketch it. Just get the intercepts and then roughly sketch the line. We just want to see, how the line look like, and then you just have an estimate of where the solution is. Okay. What is more important is, of course, to be able to do the method of substitution to solve the problem. So we are done with the system of linear functions or equations. All right. Before we move on, any question, any comment, anything?
Yeah.
Sir, where's the question is again?
Tadi sini satu ni. Question 6 to 8, 11 to 17.
Question
1.5.
is in the Google Classroom. Is it, sir?
Oh, no. Everything is in the book.
Or in the book?
In the book. Actually, classroom, I only know classroom for you to submit the homework. Yeah. I don't learn more than that because I don't, actually, I do not know what to use, how to use the classroom. I only know this classroom. Our classroom is Zoom. Okay, to use that classroom as a classroom, saya tak belajar lagi. Susah nak belajar. Dah tua-tua ni, nak belajar benda macam tu dah tak raya. Okay, I want to learn other things. I don't want to learn that kind of thing. Classroom is only for submission of homework dengan test. If you know, there are other usage of that classroom, but I am sorry, I don't know those. Right. So for us, our medium of learning, our medium of instruction or interaction is mainly Zoom and WhatsApp. Itu dia. Okay. Classroom tu untuk submission ya. Right. When you submit to classroom. I will check. I'll give you the points. That's it. Because that's what I know. Okay, for the classroom. Okay.
Oh, thank you,
All
sir.
right. Question for the homework I give you here. Balik rumah, buatlah. Okay. And make sure you get the book. All right. Again, for those people who come in a little bit late, you check the first class, the recording. There is the course outline. We discussed a little bit. Make sure you go through those, and then check the notes. Okay, make sure check the notes from the beginning. We have to do some extra work. Okay, all right. So we take a short break, as I saw. We will come back, and then I will look at 1.6. We start with 1.6. Okay, I'll see you after. Assalamualaikum. Are you still here? All right. Now let's look at application. Application is 1.6. There are two main applications here. One is the break-even. So we're going to look at two. One is the break-even problem. Okay, break-even problem. The other one is problem of market equilibrium. Both of these are economic application. So let's start with break-even. So now, what does break-even mean? What is break-even? Break-even is what? If you are doing a business, you do business, you sell a product, you get revenue, and of course, in order for you to operate the business, you incur costs. Okay, there are so many types of costs. So what is break-even? In everyday term, what does it mean? Break-even. We don't have to know. You don't have to study economics in order to know what is break-even.
No profit, no loss.
No profit, no loss. All right. No profit, no loss, meaning what? What you earn through revenue, just cover the cost of operation. So that is what break-even. So let us define. So the revenue just cover cost. All right, just cover the cost. So that is no break-even. So in order to do that, you know revenue, you know cost, and from these two, okay, we get profit. So we're going to define profit, denoted by P as equal to revenue minus cost. So R, okay, R is the revenue. So R is notation for revenue. Cost T is to denote cost. So R is your revenue in dollars or M in monetary units. Same thing, cost is in dollars or RM. And therefore profit will be also in dollars or RM. Okay, so these are the units of the three variables. So you have profit equal to revenue minus cost. For break-even, all right, for break-even, BE, okay, means break-even. What is the condition? The condition is revenue just cover the cost. Revenue just cover the cost. So in other words, the profit is equal to 0. So P equal to 0. So that's even. Now, since P is equal to R minus C, okay, so therefore, what do I have? I have R minus C equal to 0. And R minus C equal to 0 means R equal to C. So, in order for us to find the break-even, to solve the break-even problem, or you want to find the break-even point, okay, break-even point or the solution, or break-even output level, the condition is P equal to 0 or R equal to C, right? Because profit is equal to R minus C. Therefore, the condition is R equal to C. So let us make use of this one. All right, make use of it. R equal to C. Because you have a system of equations. So let's consider revenue function. So first, what we need is your revenue. Okay, revenue function. And then we need the cost function. Both here linear. Okay, senang cerita, linear je. Linear. So you got a system of two functions. So you got revenue, I got C. So two functions, both linear, and we have a system of equations here, two equations. So we can apply what we learned earlier to solve for the system. Okay, for the system, that means you want to find the solution. So given R and C, you want to find the solution here. What is the solution? The solution is the break-even point. All right. Now, what is the break-even point? It's the output level. Okay, output level, the output level, call it X. That solve or that satisfy, okay, satisfy both R and C functions simultaneously. So what you need is, of course, revenue function, cost function, because the condition for break-even R equal C. All right, so let's start with revenue. Revenue denoted by R. It's a function of output, functions of the quantity of the product that you saw, that you sell. Alphabet. Right? Ada azan lagi satu. Bukan tadi dah azan ke? Okay, so it's okay. We already stopped at the end. So this one is okay. So the X here, okay, X here is the quantity of output. In other words, the product lah. All right, the product. Quantity of output sold. Okay, so that is, and revenue R is the revenue in dollars or RM. Okay, so you have revenue function of X. How do we get revenue? In order for you to get the revenue, we have to know the price. Okay, so we know the price of the product or the good, call it P. Okay, and P price, that is in terms of dollars per unit. Okay, that is the unit for the price, or RM per unit, or whatever your unit is. Maybe rupiah per unit, or yen per unit, or rupees per unit. So you got the price. Say, the price is 3.5 RM. Price P is equal to 3.5 RM. And this good that we are selling the product, suppose 3.5, apa benda yang price 3.5. Suppose this is we sell nasi lemak. Okay, nasi lemak. Okay, 3.5 per pack. So price per pack. Now, how do you get your revenue? Given the price is 3.5, how do you get your revenue?
You multiply price with the output.
You just did, multiply the price with what? With how many you sell, all right? So revenue is equal to, I'll use another, revenue is simply equal to P multiplied by X, the price multiplied by whatever you sell. So in our example, revenue is 3.5X. 3.5, which is the price, multiplied by whatever quantity we sell. Suppose, okay, we sell 100 per day. For that day, 100. So the revenue is equal to 3.5 multiplied by 100. So you get 350. Yeah, 350. 350. So that is your revenue. Okay, so revenue is a simple linear function. So revenue is just equal to Px, the price, and that price is of course given, okay, or in other words, constant. So the price is given or constant. So our example is 3.5. So that is our revenue. Revenue is 3.5x. Okay. So revenue, if you don't sell anything, you don't get anything. All right, your revenue is only earned for if we sell some output. If you sell zero output, then there'll be no revenue. Okay, all right. If you draw the graph or sketch the graph of the revenue function and linear function, how does it look like for this kind of function here? You just have, say, 3.5x without the y-intercept. So how does the line look like? And the price, okay, I want to say here, the price is positive. You cannot have negative price. Okay? Price positive. So how does the revenue function look like? You sketch, okay? Sketch the line and tell me, how does it look like?
Positive slope.
Positive slope, number one. Number two.
There will be solution.
Belum lagi, because we only have one line. Okay, to find the solution, you have to have the other function, cost. Now, don't worry about the cost. Just look at the revenue. How does the line look like? So that you tell positive slope. Okay, then we know it's going upward. Okay, positive slope, that means it's going upward. Okay, that's one. Okay, another character. What is it?
Y-intercept is 0.
Y-intercept is 0. It goes through what? It goes through the origin. It goes through the point 0, 0. So if you can see here, the y-intercept, okay, y-intercept b, that is equal to 0. So your revenue function, if you sketch it, where does it pass through the graph? You pass through this point. Okay, so that is revenue. It's always passing through that point because intercept is 0. There is no intercept. So special, special function for revenue. Okay, all right. Now, second, we are going to look at the cost function. Now, cost function, you have to relate back to economics. So cost is not as simple as revenue. So cost denoted by C, okay? What we want is, of course, the form mx plus b. You have, the constant, the y-intercept, which is here the c-intercept, and then x. So I should start a little bit. I should start, earlier. I should start. What is cost a function of? Okay. So again, here we just go by the revenue. The cost is a function of x, where x is the quantity of the output, the quantity of the output or the product produced. Okay, it's not sold, produced, because if you produce, you don't sell, you still incur the cost. So it's produced. So whatever the units are, okay? And then C is the cost in, cost in what? In dollars or RM, right? So in monetary units. So the higher the cost, not the higher the cost, the more output that we produce, the cost would be higher. Okay, just like revenue. All right, and you want to find the cost function. So general form, the slope intercept form, mx plus b. If you start from there, mx plus b. Now you have to know what is this, right? You have to relate back to economics. Now, if you have taken the economics principle, normally when you talk about cost, how do you discuss cost? In terms of the components of cost. Anybody has taken principles of economics? Or if you have taken economics from high school, all right? What are the components of cost in economics? Anybody remember? Hello. Are you here? Are you not? You are not there.
Sir, may I answer?
Yeah, go ahead.
All right. If I remember correctly, at least, usually when we calculate the cost, we take the total material cost and subtract it from the quantity produced to get the cost of one.
That would be very, very, very general. Now, in terms of economics, did you remember how do you break down in the cost that you were saying? The cost of material, the cost of labor, the cost of labor, the cost of factories, things like that. You break it down into two parts. What are they? Do you still remember?
Fixed cost.
Fixed cost and variable cost.
Fixed cost, variable cost. So cost is consisted of two components. Like what you said, from what you said, it will be what? You can break down into two, variable, fixed cost. Now the fixed cost is the cost that it's a constant, okay? The cost that is a constant. That means that is the B-intercept, not the B-intercept. That is the constant B, okay? That B is fixed. It doesn't vary with output, okay? It doesn't change. Doesn't vary with X. Whether you produce 1 unit, you produce nothing, or you produce 100 units, you will have to incur that cost. All right? Now, example, what kind of cost normally we incur fixed, regardless of whether you produce or you don't produce? Example, the rent. Okay, the rent to your what? To your machine. Okay, capital cost. Okay, so capital cost normally fixed. If you buy the machine, the cost to the machine will be incurred, whether you produce or you don't produce. So that is fixed cost. Now, the other component of cost is the variable cost. That variable cost is the component of the cost that change with output. If you want to produce more X, you have to incur more of that cost. All right, so the cost will be higher. So that is the variable cost. Okay, the component of the cost will be higher. If you produce less, you can adjust the variable cost will be lower. Okay, what is the cost? What kind of input which you can adjust quite easily? You know, you COVID-19 time, you know, your factory produce very little output. What other input that normally you can just delete, you know? And then when you produce more right now, you know, COVID-19 is getting better. Firm factories are producing more, so you will hire the input very easily, more. What? Workers. Okay, workers, very easy. You want to hire more, you hire more workers. You produce less, you hire less. For example, during the COVID-19 pilot, okay, there are so many pilots that went out of work because the airplanes are not flying. The airplanes are supposed to fly in the air, not to travel on the ground. So pilots ramai kena retire. And now, you know, when international travel is allowed slowly, pilots are starting to get jobs. So labor or workers are quite easy to adjust. So you got variable costs, which depend on the output level, and we have the fixed cost, which constant. So the cost function will be equal to mx plus b, right? So that is the cost. So mx plus b, and b is a constant, and m is also constant. So b and m are both positive. Okay, the slope of the cost function will be positive. The intercept will be positive. So example, you have something like this. C equal to 20.5 x plus 2,100. Apa ya? Udah banyak itu. 6,100. So that is example. All right. So you have the cost, and I have the revenue. Okay. All right. So I think I will stop here. We will continue on. We'll continue Monday. Monday next week. All right. So I will put the recording. You know, I have already put the recording from last week. Okay, last week. So make sure if you miss any of the class, please refer back. Okay. I would like you to, you know, to get back from the beginning, so that as we continue, everybody will be at the same level. Okay. So that you don't have to wonder, you know, what happened last week. You know, I do not know what's going on. So make sure you go through, you know, get the notes from your friend, or I already put the recording. So make sure do that. Okay. Because at the beginning, there are only 18 people. First week, I have only 18 people. By second week, double the number. So make sure those people who came in late, you have to do the extra work. Okay? You have to do the extra work. Next week, probably I will give you some homework. Okay? All right. Any question? Anything? Tak ada apa? Okay, good.
Yeah.
I will see you again next week. Have a nice weekend. Stay study, okay? Don't enjoy yourself, study. Don't go out too much, you know. Even though you can travel, COVID is still here, you know. We have still 5,000 cases. 5,000 cases is still a lot of numbers. So take care, okay? Take care. Don't be too excited to go out, all right? Take care. This is still, you know, we are in danger. So I'll see you again. Have a nice weekend. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you, sir. Thank you, Doctor.
Thank you, sir.
All right, thank you.
Thank you, sir.
Okay, thanks.
Thank you, Doctor.
Okay.
Yes. Doctor,
Yeah.
I just joined today about the group, so we need like 3 people. Sir.
No, only 2 people.
Oh,
Okay,
two.
no, not 3 people, only 2. Okay, I don't want 3 because 3 will be too many. I want 2 so that you can discuss and you can work together. All right, 3 people, too big because 3 people, the third person will just do nothing. So I want only 2. Okay, all right.
So another thing, sir, about the last week's video, where is it? Where is it? On WhatsApp.
Dekat WhatsApp. You
WhatsApp,
scroll up WhatsApp tu, ada link. Saya bagi link.
Okay.
Okay.
Thank you, sir.
All right. Okay.